Right. So here is our chapter 9 test review. We're going to go over all these questions, go through the different formulas we're going to use for these, and ultimately go through each problem with their answers. So for number 1, it says find the circumference of a circle. Remember, we learned that circumference is equal to pi times diameter. Okay. So in this case, right, we use pi as 3.14. My diameter is all the way across the circle, which I see there is 9. So my circumference ends up being 28.26 when I multiply 3.14 and 9 together. It's not centimeters, it's feet, right? For number 2, though, the difference here is that we're actually solving for area and not circumference. Okay, so be sure to look which one is it actually asking you to solve for. The reason for that is that our area formula is a lot different, right? It's pi times radius squared, or sometimes we think of it as like pi times radius, right? Instead of using diameter, now I'm switching to use radius. Well, I'm given a diameter here, meaning I only really want half of this. Half of 22 ends up being 11. So when I solve for my area, I'm going to use 3.14 for pi. My radius is 11, and we're going to multiply that by itself. So I have 11 times 3.14. My area for this is going to be 379.94 inches squared. For number 3, I'm solving for the area of a semicircle. Very similar to number 2. For a semicircle, though, right, we think it's half of a circle. I need to divide my answer by 2. Again, area is pi times r times r. For this one, right, I'm going to cut my diameter in half to get the radius. Half of 16 is 8. So I'm going to use that. Should do that. I have 3.14 times 8 times 8. And then we'll divide our answer by 2. 3.14 times 8 times 8 divided by 2. I get an answer of 100.48. And this will be square centimeters. All right, number 4. Number 4 is a little different in the sense that I have like 2 different shapes we're solving for. Right? We're going to use 2 different formulas here. For a rectangle, we've known this for a while now. That's just base times height. For my triangle, it's base times height, but then we divide by 2. 3.5 is my base, 1.5 is my height for my rectangle. So if I do that, 3.5 times 1.5, I end up getting 5.25 for my area of the rectangle. For the triangle, then, my base is 4. My height is really just this length again, which is 1.5, and then we divide that by 2. When we put that into our calculators, we get an answer of 3. Now, to find the total area, it's just as simple as adding my 2 areas together. 5.25 plus 3, that's going to be 8.25, and this is square kilometers. All right, 8 and 9. This is where we're kind of stepping away from the area part and we're looking at angles, right? For number 8, it's telling us to find the value of x. I actually like to look at like what type of angle do I have here. I see that I've got this straight line on the bottom here with 2 angles coming out of it. So I know that this is supplementary. Supplementary meaning 2 angles that add up to 180 degrees. Because of that, I know that whenever I'm done, these 2 need to be equal to 180. Well, what 2 angles are making up 180? I have 145, that's this part, and my other part is made up of this like x plus 10. So I know that put that all together, I should end up at 180. Now we're just going to do some simplifying and solving. Combining like terms here, 10 plus 145 is 155. We're going to add back everything I didn't touch. Now to get x by itself, I see plus 155. I need to subtract by 155. After I do that, I'm left with x is equal to 25. All right. Number 9. Number 9 looks a little bit different, right? I see a straight line, but There's a whole bunch of other ones going on here. What we actually have here is something that looks like this. I see that I have two straight lines. There's one, there's two that are intersecting. Now, whenever we see two straight lines that intersect, we have these angles that we call vertical angles, right? Vertical angles are always across from each other and they're equal. So by those two straight lines, I have these two angles, which are vertical to each other, and they are equal. We're almost essentially kind of ignoring this line right here, and we're saying, hey, that whole side over there is x plus 30 and 2x. The other side is 150. Since they are vertical angles, they are equal to each other. So I'm going to say, hey, 150 is equal to this x plus 30 combined with 2x. Both of these combined give us our total angle right there. To simplify this one, combining like terms, I have x and 2x, right? I'm adding another x to 2x. That makes this 3x. We'll put back everything we didn't use. Now, I can't get rid of the 3 first since it's attached to x, so I need to get rid of anything that's addition or subtraction. This is addition, so I'm going to subtract 30 from both sides, leaving me with 3x equals 120. From there, right, we just need to divide by 3 since x is being multiplied by 3. 120 divided by 3 gives us an answer of 40 degrees. Moving on to the back side. We'll start with question number 11. It says that a regulation soccer ball has a diameter of 9 inches. A souvenir ball has a diameter of 3 inches. How many times larger is the circumference of the regulation ball than the souvenir ball? Now, there's a bunch of different ways we can approach this problem. What I typically see is this, right? All right, I have this regulation soccer ball that has a diameter of 9. I have a souvenir ball with a diameter of 3, and it wants us to find the circumference of both. So, if we start by doing that, circumference of the regulation ball, well, that's just pi times diameter, meaning I'm going to do 3.14 times 9. That gets us to 28.26. We did that before. The circumference of my souvenir ball, again, is pi times diameter. So I'm going to do 3.14 times 3, and I get 9.42. All right. Now, it says how many times larger is that the regulation ball than the souvenir ball, right? If I'm looking for how many times larger, I'm looking really at how, what's the scale factor there, right? How much bigger is that one than the other? To find that, we're actually just going to divide these two numbers, 28.26 and 9.42. When I divide these two, I actually get an answer of 3. My soccer ball, my regulation one, is 3 times bigger than the souvenir, which makes sense, right? If I look at their diameters, 9 and 3, well, if I divide those two, I get 3 again. So when we look at just circumference, if I go up times 3 from the souvenir to the regular size, my circumferences do the exact same. And we see that, right? Because both of them are just being multiplied by the exact same thing. Either way you do it, 9 divided by 3, or 26.2, or 28.26 divided by 9.42, we're going to get an answer of 3 times larger. Okay. Number 12, a circular rug has a radius of 7 feet and is placed in a room that is 14 by 18. How much floor space is not covered by the rug? So let's put some measurements here. It says the long side is 18, short side 14, and this has a radius, right? So halfway across of 7 feet. Okay? It's asking how much floor space is not covered by the rug. Floor space meaning kind of the area. So we're going to be looking for the areas of these two. So what we're going to do first here is we're going to find the area of the room, and then we'll find the area of the rug, and we'll just kind of subtract the two to see what's left over. So the area of my room is simply a rectangle, which is base times height. So 18 times 14 I get 252 square feet. The area of my rug, we're going to get by doing pi times r, which is 3.14, times 7. 7 is my radius, so I'm good there. And when we do that, 7 times 3.14, I get 153.86. Now, just like I said, right, if we want to look for how much is left over that isn't covered by the rug, we just need to subtract these two numbers, right? 252 goes on top, it's the bigger one. 153 on the bottom, 0.86. I need to do some borrowing here. 9, 10. This is 4. This is 1. We need to borrow from our neighbor again. 8. One more time. 9, and that goes to 0. So the floor space not covered by the rug remaining is 98.14 square feet. Right? That would kind of be like all of this stuff right here and all of that stuff right there. Okay, 2 more to go. Number 13 says you're responsible for fencing and seeding a particular parcel of land. The fence costs $4 per square foot. $4 per foot. One bag of seed covers 80 square feet and costs 120. What is the total cost of the project? Lots going on here. If we break it apart, it actually becomes really nice, right? We're working with triangles and rectangles. Those are kind of a little bit easier, I think, than circles and semicircles. Okay, so we have to look at fencing, which is perimeter, and we have to look at seeding, which you're not going to seed the edge of your yard, you're going to seed the whole part of it. So we're looking at area. Let's start with perimeter. My perimeter is made up of all these outside lines. So here, here, there, 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 and there. Only those in red are what I'm dealing with right now. So my lengths are 80, 50, 30. These two are the exact same. So I know that this is 80 down here, 30, and 50. When I add all those up, I'm going to get a total of 320 feet. Okay. With that being said, it is saying that the fence costs $4 per foot. Well, I know how much feet I need. It's right here. So all I need to do is take this 320 and multiply it by 4. 320 times $4 per foot gives us a total cost of the fence of $1,280. Now, for our area, right, our total cost is made from the fence and the seating. Our area is a little bit different, but not too bad, right? For my area, I'm dealing with 2 things, or 3 things, but we can kind of combine 2. These 2 blue triangles, if we look, have the exact same dimensions. It's 50, 40, or 50 and 30, and then has a height of 40. Same thing on the other side. The other part we're going to need as well is kind of this main chunk of the yard that is the shape of a rectangle. You can start any way you want. I'm going to start with the rectangle. All right. To find the area of my rectangle, I'm going to do 80 times 40, base times height, and I get an answer of 3,200 square feet. For my triangles, right, I still need to do this base times height divided by 2. And when I find the area of one of them, it will just match the other since they're both the same triangle. Okay, a lot of people are going to use 50 for the height. That is not my height. That's my slant right there. Remember, I need the height of the triangle, which happens to be 40, just like the other side. So we're going to do 30 times 40 and divide that by 2. 30 times 40 divided by 2 ends up giving us 600. So I know this triangle has an area of 600, and this triangle has an area of 600. To get my total area, I'm just going to add them all up together. Whoops. There we go. 600 plus 3,200 plus 600. When I add those all up, I'm going to get 4,400 feet squared. Couple things extra we have to do with this. Let's read this. One bag of seed covers 80 square feet. All right. So if I want to figure out how many bags do I need, I'm going to take my 4,400 square feet, and I'm actually going to divide it up into sections of 80 to see how many bags do I need. Now, when we type that in, 4,400 divided by 80, we get a nice solid answer of 55 bags. But again, I'm looking for a final cost, so I need to know how much does each bag cost. Well, each bag costs $1.20. So we're going to multiply by $1.20, and we're going to get an answer of $66. Each bag costs $1.20. There's 55 of them. We have a total cost of 66. What is the total cost of the project? That is our final question. Well, we have our two costs, 66 for the seed, 1,280 for the fence. Add them both together. We are going to get an answer of $1,346 in total. All right, last question. Number 14 says the measure of angle 1 is 70% of the sum of the angle measures of the triangle. Find the value of x. So there's a couple important things we need to know. One, the sum of angles for any triangle is 180 degrees. That is true for any triangle you could think of. A right triangle, an obtuse triangle, an acute triangle. Any triangle, if I were to take all three of its angles and add them up, they will always equal 180 degrees. Why is that important? Well, if we think about it, that's really a total, right? The total, or a whole, is 180. What I have here is I have a percent, I have a whole, and I'm missing a part. I'm missing, well, how much is angle 1? That's a specific angle of the total angles. So we're actually going to set up a proportion here. A over W, P over 100. Here's what we know. I'm missing my part. I don't have my specific angle, but I do have my total that I know of 180 degrees. That's for any triangle. My percentage that it tells me is that angle 1 takes up 70% of this 180 degrees. So however much 70% is, that is angle 1. Now this is nice. We're just going to do some cross multiplying here. 100 times A is 100A. 180 times 70 gives us 12,600. To get A by itself, we divide by 100. And I get A is equal to 126 degrees. That is the measure of angle 1. Which makes sense, right? We see it's an obtuse angle. Obtuse is bigger than 90, smaller than 180. What's left over is, well, I have two x's here. And really, I can make an equation. I can say that the total sum of angles is equal to, well, I'm going to add 126. I'm going to add this angle, x, and I'm going to add that angle, x, together. Now, we've just got our equation again. Combining like terms, I have 1x and 1x. That's going to combine to make 2x. From there, I need to get rid of anything not attached to x first. That would be this 126. That's going to leave 54 equals 2x. And then finally, dividing by 2 on both sides, I see that each of these x angles is equal to 27 degrees. This angle is 27 degrees. This angle is 27 degrees. Right? If I wanted to check, I could add all of these back up. 27 plus 126 plus 27 which indeed does equal 180. So we found our value of x being 27 degrees. Okay, there is our Chapter 9 test review. Go through with your sheet. If you needed help, make sure you answer those problems, and best of luck on our test.